Hello again, welcome to another lesson in geometry. Today we're covering section 9-2, reflections. Okay, so this is our second transformation, and it's an isometry transformation also. It will not change the size of the shape. All right, so we have some review first. Number one, circle the translation rule that shows a mapping of 2 units left and 1 unit up. So remember the X is going to control our left and right, so we want to go 2 units left. That could either be this rule or this rule. So the one in the middle we're definitely going to cross out. And we want to go 1 unit up. So the Y controls the up and down, and that should be a +1. So we're going to keep this rule and scratch out the other 2. Okay, so this rule is 2 left, 1 up. All right. Vocabulary builder, a reflection. So a line of reflection is a related word. We need a line of reflection. Think of it as the mirror, okay? And the definition, a reflection is a mirror image of an object that has the same size and shape, but the opposite orientation. That means we're flipping the object upside down using the mirror as our way to flip it, okay? So math usage of reflection is a transformation where each point on the pre-image is the same distance from the line of reflection as its reflected image, okay? So the pre-image just gets moved across the line of reflection and the same distance it was, so perpendicular bisector was going to be needed here, okay? All right, so use your vocabulary, write T for true or F for false. A reflection is the same shape as the original figure. This is true. It's going to still be congruent. And a reflection makes a figure larger, and this is going to be false. Is an isometry as a reflection, so it's not going to change the size, okay? All right, key concept here, reflection across a line. Reflection across a line R, called the line of reflection, is a transformation with the following 2 properties. If a point A is on the line R, then the image of A itself is the same thing. So A and A prime are going to be exactly in the same spot. If a point B is not on line R, that's this one up here in our pre-image, then R is a perpendicular bisector of, BB prime. So this is BB prime. Okay, so it's moving B from the pre-image to B prime, the image, and that's going to be perpendicular to our line of reflection. Okay, so there's our line of reflection. And then B and B prime will be the same distance away. Okay, so reflection across a line is an isometry. And line, let's see, R is the perpendicular bisector of C prime. So if I connect it, C to C prime, we're going to get a perpendicular form for our angles. And this length would be the same. Okay, on the top of page 2 here, we have our big problem number 1, reflecting a point across a line. All right, so it's broken down into a bunch of parts here. And the main question says this: what is the image of P, who's at 3, 4, when it's reflected across the line x equal to -1? So our step 1 is to graph P on the coordinate plane at the right. So 3, 4 is 3 to the right and 4 up. And we'll put P here. So this is our pre-image of P. And we want to get the image after we do a reflection. All right, so describe the line of reflection and then graph the line of reflection. All right, so the line of reflection is going to be x equal to -1. It tells us this here. And this is a vertical line. Remember, if you forget, you can make a little table. This says x is always -1 and y can be anything you want. And if you plot those points, you're going to get this line of reflection right here. Okay, so this is going to be x equal to -1. Okay, so the distance point P from the line of reflection is 4 units. And that's because if we went up here and measured it, it would be 1, 2, 3, 4, and that's going to form a perpendicular. So that's easy to see. Underline the correct words to complete each sentence. The x coordinate of P and P prime are definitely going to be different here. Okay. One's going to be at 3 and the other one's going to be in the negatives. The y coordinate of P and P prime are going to be the same though. Okay, so this going straight across, so the one go over here will still be the same height at 4. Okay, so point P is reflected to the, let's see, P is over here on the right, so P prime when it gets reflected will be on the left. So it'll be on the left across the line of reflection. Okay, so graph the image of P34 and label it P prime. All right, so we know that we need to make this be the same distance. So 1, 2, 3, 4. So here's where P prime is going to be. Okay, my P image of P is on the right, and the image is P prime is going to be on the left. It's still going to form a right angle. Okay, and make that a little better. All right. And then, let's see, graph the image 3, 4, and then the coordinates of P prime are at -5 and 4. So notice it has the same y coordinate as our original. We didn't change that because we were reflecting it kind of just horizontally. And then our x coordinate is definitely going to change because we are reflecting it horizontally. All right, problem number 2. Big problem number 2. Graphing a reflection image. So graph points -3, 4, 0, 1, and 4, 2. This is going to be our pre-image. And then what is the image of ABC, triangle ABC reflected across the x-axis? So we're going to graph our points and then we're going to reflect across the x-axis. Okay, so this time we're going to reflect up and down. So the x-axis is the same as a line y equal to 0. And remember that's because if we put 0 in all the y spots, this can be anything we want, we end up with a line on the x-axis. Okay? All right, so circle the distance in units from point A to the axis. So they already plotted point A for us. It's right here. And the distance, so it forms a perpendicular to the x-axis, will be 1, 2, 3, 4. So this is going to be, circle will be 4. Okay. And then it says underline the distance from point B to the axis. So point B is right here. And a perpendicular to our line of reflection, which is the x-axis, is only going to be 1 long. So we're going to underline 1. Okay. And then it says put a square around the distance from point C to the x-axis. Remember, x-axis is our line of reflection. So C is 2 away on the perpendicular. So we put a square around that. All right, so that means we didn't use 3 or 0. So point B prime is, let's see, going to be 1 unit below the x-axis. Okay. And point C prime is going to be 2 units below the x-axis. And the arrow shows how to find vertex A. Graph the image of ABC and label it. All right. So we moved A by moving it 4 down below here. And that's why it ended up there for A prime. B prime is going to be 1 below. And C prime is going to be 2 below. Okay. So if I graph this, I get this triangle. Okay, which is going to be congruent to our original image, our pre-image, and it's because all the links are going to be the same, and all the angles will be the same. So this one and this one are the same, this one and this one are the same, and this one and this one are the same, along with all the corresponding angles. Okay, on page 3, we begin with big problem number 3, minimizing a distance. So we have got it here, and it says the diagram shows one solution of the problem below, and your classmate began to solve the problem by reflecting point R across line T instead of the O across line T that they do in this example here, this solution. Okay, so first we're going to talk through how this solution works after we read the problem. So here's what's going on. Summit Trail is line T. That's this trail that's already built. Okay. And there's a hiking club, and they want to build trails that go from the same spot on line T so that you can get to point O, Overlook Pass or something like that, and to Balance Rock. And of course, they're lazy. They don't want to make the trails longer than possible, so they want to find the shortest distance that they can do. So if they pick point P, they want to find the shortest possible distance to make the trails. Okay. All right, so they could put P anywhere on line T. All right, but this is going to be the best place, and let's see why. So the way that they showed it was first they reflect O across T. Okay, so that's going to form a perpendicular bisector with these links the same. And when they're done, they have O prime over here. Okay, and then they said, okay, well, O prime is the same distance away from the trail as O is. So we can just think of it this way. All right, we have 2 points, O and R, O prime and R, and the fastest way to get through them is a straight line. And the place where that line crosses right here at P will be the best place to build our trail, because that will minimize the distance, because it's the same distance here as it is here. Okay, so in either case, O or O prime, think of them as being the same distance away from the trail. So the fastest way to get from R to O is the same as the distance from R to O prime, which is a straight line. And that's how they found P. All right, so your classmate did the problem a bit differently. Instead of doing the first reflecting O prime, your classmate tried to reflect R prime. So they did this reflection. And we want to see if it will still give us the same answer to see if they did it right. All right, so put a check in the box if the response is correct. Place an X in if it is incorrect. So let's give this problem a try again. Okay, so first off, let's see. Here's our trail, same as before. And when point R is reflected across line T, T is perpendicular to bisector R prime. So let's do our reflection here. We'll go across. Here's going to be R prime. And these should be perpendicular because we did a reflection, and they should also be the same length here. Okay, so this is a check. PR is a different length than PR prime. This is not a check. Okay, and that's because PR, which is here, should be the same distance as PR prime there. Okay, there's going to be similar triangles in there. All right, so RP, okay, that's this one, plus PO, that's this one. So those two added together should be equal to, let's see, R prime P, which is here, and PO, which is also here. And that's going to be true. Okay, 2 of the segments are right on top of each other, so they're same length, and we already showed that R prime P and RP are the same length. So this is going to get a check. And then it says points OP and R prime. So here's O, here's P, and here's R prime are not collinear. Well, that's definitely wrong. They form a straight line. So the trail should start at point P where O, R prime intersects T. And this is true. Okay, that's where we should put our trail. Kind of the same ways as they did up above. Okay. All right, so let's try this all the steps through. Reflect R across the diagram at the right and label the reflection R prime. So when I do my reflection, I'm going to draw a perpendicular. That's 2 segments long. So this new one should also be 2 segments long. So this is R prime. All right. Now, draw R prime. We already did that. And draw R prime O. Okay, so R prime O. Let's see if we can draw this in straight. Okay, so 1, 2, 1, 2. All right, do our best here. It'll look something like this. Okay. All right. Label the point where R prime O intersects with line T as point P. So here's going to be point P right here. Okay. And then draw PR. Well, okay, we can do that. Here's PR. Okay. What do you notice about point P after reflecting R across line T? All right, so here's a possible answer you might write. I'm going to say something like this. Reflecting point R across line T locates the same point P as found in the solution in the diagram above. Okay, so we got point P in the exact same spot. So will your classmate's method work? This should say yes. You found the same place, right? And then we have to explain. And your method could say, oh, all right, her method found the same place as the method above. Because in both cases, you're doing the same thing. In one method above, let's go ahead and draw it here. They're reflecting O. So this is 4 away. 1, 2, 3, 4 away. All right. And then when you're done, you have that straight line. And oh, look, remember, see the P matched in both. And that's because they're doing the same thing. You're just reflecting it to form the, move the point over and then finding the straight line that puts the 2 points together. And that straight line is going to be the same no matter which one you reflect first. All right, let's flip it over and try the last page. So as always, the last page here is a lesson check. And pause the video, give it a try yourself, and then come back and check it over. Okay, welcome back. Hopefully you did a lesson check and found some shortcuts for reflecting points across the X and Y axis. All right, well, the big question here, what are the coordinates of the point XY after it's been reflected across the X axis and the Y axis? So we have a number one, 29. Reflect point P across the Y axis and then label the image P prime. So here's our Y axis. Okay, we're going to form a perpendicular bisector. So bisector, so this is both 3 long, perpendicular, and that means P prime is going to be right here. Okay, number 30 says circle the coordinates of point P. So point P was at -3, 1. And then it says circle the coordinates of P prime. P prime is at 3, 1. Okay. Describe how the coordinates of P prime are different from the coordinates of P. And you should just say this. The only difference is the X coordinate changed to its opposite. That's it. So it just did a quick change. So if you change -3 to +3, okay, because we're flipping it over the y-axis, so only the x coordinate is going to change. The point will stay at the same height. All right. Then you're asked to reflect point P across the x-axis and label the image P double prime. So here is our x-axis, and we're going to reflect it over. So this is going to make a perpendicular bisector. So these have to be the same length and have to form right angles. And then here's going to be P double prime. All right, so label the coordinates of P double prime, and the coordinates of P double prime are -3, -1. So how did that change from the original P? So it went from -3, 1 to -3, -1. So describe how the coordinates are changed. Only the y coordinate changed to its opposite. Changed to its opposite. That's it, just the y coordinate. The x coordinate stayed the same. All right, so the general rule here, if you have some point xy and we reflect it across the y-axis, okay, that means that it's still going to be at the same height. We're not changing its height. All we're changing is its left and right, and we're going to change it to the opposite of where it used to be. Okay, and if we changed it by reflecting across the x-axis, then it's still going to have the same left and right. Okay, we're just going to change its up and down, and the new up and down will be the opposite of what the old up and down used to be. All right, so check out the vocabulary words that you understand. Hopefully you're good at reflection. You understand what that means. And do a reflection, we need a line of reflection, so it's hard to not understand that one if you understand the first one. And hopefully you're in here. If not, watch the video again and then come for some extra help. See you in class next time.